I want to welcome all of you right now to the new topic on probability distribution, which is known as the normal distribution. Normal distribution. Now, by the end of this, you should be able to understand and explain normal distribution, exponential, uniform, gamma. Some of them we already know about. So it's important that you apply them. But let's recap a little bit about what is a continuous random variable. Now, last time we looked at a discrete random variable. What is the difference between a continuous and a discrete random variable? A continuous random variable is inclusive of decimals. Even if they are whole numbers, they are also decimals. And it can take a range of values. Within an interval, it can have a range of values. So the probability of any particular value occurring is not possible. It's zero. Because we don't deal with a particular value occurring, but we deal with a range of values occurring. Okay. So, how do you explain or describe a continuous random variable, which is known as X? How do you define the cumulative density function? The cumulative density function, which is f of X, is defined as the probability of X less than or equal to the variable in question. That is out of the range, one of them, for all X, which is a member of the random variable. So if you have the random variable, which is made up of 0 to 10, inclusive of decimals, X will be like 5.4, one of them. Like any other distribution, I told you that we need to know the variance and the expected value. The expected value is the mean, the average, and the variance is the spread. And for a normal distribution, the expected value is given as, the density function, the expected value of the density function is given as X multiplied by the function. And the variance is also given as X squared multiplied by the function minus the expected value of the random variable squared. And this is an integration. So you have an integral function from a negative to positive infinity. Now, this thing might not make sense, but they don't really, you don't need to bother so much about them because you're going to see them. And you can see that when you observe them, you see that they are very easy, simple to understand. Now, let's take a simple example of a particular random variable that is normally distributed. Height. Height is normally distributed. Why? Under what circumstance can we say that height is normally distributed? Because majority of people in this world have got the same height, similar height. Now, in this college, there is an enrollment of 3,264 female students. On the first column, you have the height of each groups of students, the frequency, the number of students who are falling within that height. So, for example, this 3 that you see here, this 3 refers to the number of people who are between 56 and under 57 height inches. And the relative frequency is almost 0.1% or so. So that's a small number of people. However, if you check those whose heights are between 64 and under 65, they make up 17%, which means that there's a number of people who are there. So with this information, you are supposed to address the following question. Question number 1, what is the relative frequency that students are going to fall between 60 and 68 inches tall? I'm interested in how you are going to work it, not exactly the value. But how will you work it? The answers are easy. What is a relative frequency that a student is going to be between 60 to 68 inches. So what will be the relative frequency? How do you work it out? Classroom.
Yes, please.
What will you do?
I think you is a relative. Oh. You sum the values from 60 to 60 under 61 to 67 under 68.
Counting the values you are talking about.
So the frequency you sum it.
What are they? Mention them.
So from 147 plus 247 plus 382 plus
Yeah, but it's not
48.
of the frequency. It's asking of the relative frequency and not the frequency.
Then let me look for the answer, please.
Okay. Ryan. Yes, Emmanuel Kimson. Emmanuel, go ahead. Richard Asamoah, go ahead.
Okay, sir. So you sum the frequencies from 0.045
Did you say
and
the frequency?
the relative frequency, please.
Okay.
So 0.045 plus 0.757 plus
All the way
0.117 all the way to 0.735.
Okay. That's all I wanted. So that is it. So you sum those that have been readed. Okay. And then when you get to that, and remember we said up to 68. Up to 68. So you will now add up those values. And when you add up, you will see that they will come up to 89.8%. That's it. Next question. What is the relative frequency that the students are shorter than 68 inches? How will you work that? The students are shorter than 68 inches.
Doc,
Yes.
may I speak? Okay, so that means you sum from you sum from 0.009 0.0009 to 0.0735.
Okay. Next time, please raise your hand for me. It helps to decolorize the whole thing.
Sorry, Doc. Thank you very much.
All right. So again, this is the shaded information for that purpose. And then finally, and when you do that, you're going to get 93%. Now, finally, it says, what is the relative frequency that the students are taller than 68 inches? That one is obvious. Taller than 68 inches, you're going to start from where I have shaded, from the frequency of 122, its relative frequency. That is below the 0.0735. Below that, and all the way to the end, because you are talking about taller than. When you do that, those are a smaller number of people, as you can see. And so the chances are just 6.9%. Okay, what you have on your screen is known as a histogram. A histogram shows the height that we just looked at. And the far value on the left are the values of the relative frequency. There is also a kernel density plot that passes through the center of each of the histogram. It is in red. This is what is known as the kernel density plot, and is also known as the probability density function. It is not the same as the cumulative probability density function, but it is a probability density function. The cumulative, I'll show you very soon. Look at it and you will note that this kernel density plot is bell-shaped for normal distribution. Again, this is the same bell shape kernel density plot, also known as a PDF, the probability density function. That's the same thing here. But then the cumulative probability density function is adding to the individual probabilities and then adding and summing them to the others. So what do you think would be the value here at the cumulative probability density function? What will be the value? What will be the highest value? What will be the highest value of the cumulative probability density function? And the highest value will show somewhere here. So what will be the highest? Yes, K4.
Dog. Hello?
Yeah, go ahead.
Hello? It will be 1.
It will be 1. It will be 1. Keep that in mind. Now, let's dig deeper into normal distribution. Normal distribution, we've indicated, is a very common distribution. It's very, very common. It was developed by Carl Friedrich Gauss. Sometimes it's known as the Gaussian distribution, taking the name from Gauss. You can apply it to height, to weight, incomes, ages, test scores. You see, most of these things, majority are around the same value. For example, many people's height are around a similar value. Majority of people all weigh between, 60 or between 50 and 70. Majority, which is 50 and 80. So there's not many people who are above 100 and not many people who are below 40. Okay. The average person. Blood pressure level is normal for many people. So many things are normally distributed. And that is why the normal distribution is a widely used distribution for statistical inferences. Very, very widely used. Now, the shape of this normal distribution is illustrated by the bell-shaped normal curve, as you can see. It is different from the exponential distribution, which is falling asymptotically, meaning that it's falling and falling without touching the x-axis. The most important thing for today, for you, is that when you look at the entire area of the normal distribution, your goal is to find the area. But we know the total area of the normal distribution. What is the total area of the normal distribution? As you look at it here, what is the total area? Well, we said it before. What is, okay. Yes, Rashid.
It's 1.
Therefore, the total area can also be called what?
That's the cumulative.
That is a probability.
Oh, that's okay. Okay, sorry.
That's a probability. Okay. So the area under the curve is a probability, or the cumulative probability is the same thing. You've not indicated the individual. The individual will add up to the cumulative. But that's the probability. So guys, write it down in your notes that the area under the normal curve is the probability. Now, the density function, mathematically, that curve is given by this formula. This formula has 4 major elements. What is the name of this first one here? It has 4 elements in it. What is the name of this first one? You can tell me. What is that?
The standard deviation.
Who's talking that out? Remember?
Doctor, that's the variance.
Hmm?
That's the variance.
That's the variance. Somebody says the standard deviation, another person says the variance, which is correct. It's a standard deviation, but it's not a sample standard deviation. It is the population. The variance is rather this one here. The x is that particular random variable. Mu is the mean, and then the pi is a natural log Oh, sorry, the pi is 2718, and then you have the exponential function as well. Natural log. All of them 3.14. All of them have got a formula for calling them. In fact, you will notice that these are some of the formula for finding them. Pi is always 3.141, and then the natural log is always 2.71. Okay. X is usually the one that will be in the question, and I think we did that when we're looking at the binomial and the pattern. Now pay attention here. I told you that every distribution has a location, which is a center, okay, as well as the spread. The center is the mean, the spread is the standard deviation of the variance. The highest point of the normal distribution curve is said to be the mode. Okay, now let's get into deeper thing that we are going to consider today. Now, who can tell me what is this that I have done here? What is that? What is it that I've done? Rashid.
You are trying to depict the skewness of the.
No, what have I just drawn?
Okay, that's the normal distribution.
No, on the left side.
The other side. Okay, that's a rectangle.
It's not a rectangle. Justice.
A square.
A square. What is the area of a square? Justice. What is the area of a square? He's lost.
Four.
Are people not raising their hands? They are just talking. Should I mute everybody? Before you can know that you have to raise them. Yes, ma'am.
Say length times breadth, or because it's a square, it's L squared.
Okay. Now, what have I drawn on the right here?
Rectangle.
Next one.
A rectangle.
What is the area?
Length times breadth.
No me.
What have I drawn here? You can raise a hand. Next one.
So triangle.
What is the area? Don't get lost. You are talking plenty. Don't get lost. What is the area?
Is half base times height.
You just
Half
remember.
times base times height.
Just remember. What have I drawn here? What is the area? People are lost. In the previous class, everybody was answering just like that. Everyone, like every hand, I could have like 30 hands up. So what is happening? You don't know most of these quadrilaterals. You don't know the parallelogram. You don't know rhombus. Okay. You don't know the trapezium and a trapezoid. You should know them. What is this that I've done on the top left here? Rashid.
That's a circle.
What is the area?
Pi r squared.
So every shape that you have has got an area. Every shape. And now we are talking about the normal distribution shape. And it has also gotten an area. What we know is that this normal distribution that you see on your screen here, the entire area below the curve is 1. That's what we know. What we don't know is how, given the mean and the standard deviation of the variance, we should be able to know portions of the area. And one way we can know the portion of the area is by defining the normal distribution using this term, x being normally distributed with a mean of mu and a variance of sigma squared. We should be able to find portions of the area. So if I give you the area to be all of this red, but there's a white space here. My goal is that I need to know the shaded area. You have to learn to know the shaded area. And I'm going to give you a couple of examples. So for example, the one on your screen right now, if I am looking for the value of X, let me tell you what I'll do. Pay attention here. If the entire area is 1, what is the value of half of the area here? Given the mean on the center, what is the value of the half of the area? That's all.
0.5.
0.5. Now, if I know that half of the area is 0.5, and then I'm supposed to find this entire shaded red area, all I need to do is to find this other portion here and add it to what? Rashid.
To 0.5.
Correct. Now, how do I find this other bit? Note that in the normal distribution, you always start reading from the center. Write that down. You forget, write it down. You always start from the center. Okay, so let's take it back here. If I want to read a portion here, okay, I want to read this shaded portion, I will start from the center going to the right. And if I have to read something on the far left, I'll start from the center going to the left. That is how you read. And whatever you read becomes that particular shaded area you dealt. Okay. Now I'm going to give you some scenario. You're going to tell me how to find these areas before we get into the practicals. Let's take this first one. If you look at this area, we have an area called B. And when I say B here, the B is standing for as if I have written the B in the space. It is standing for the shaded area to the right of the mu, which is the center. And A is also as if you're talking about this portion. So if I want to be able to find this shaded area number 1, what will I do? You can tell us. What will I do? Not so.
You add A and B.
A to
A plus B.
A plus B, right?
Yes, please.
Correct. What if you want to find this shaded A area? Let me give you B to be here. Let me give you C to be here. If you want to find the shaded area, which is the last bit on the far left, how will you find it? You got to be careful here. How will you find it? Deku?
You add C plus B and then subtract it from 1.
Yeah, that's what you do. But you will notice that the table I'll give you will not have the 1. It will have the maximum value to be 5. So how will you work it? It will have the maximum value to be 5.
You subtract C from 0.5.
Yeah. Why do you have to subtract C from 0.5?
Because we start reading from 0.5.
Excellent. I love you for that. That is exactly what I wanted. Because start reading from the center. So you will always bypass C before you go to A. I'm giving so many marks in my head. And when I start pouring them down, others will understand. Now let's go to the last one, the third one. How will you find the 2 shaded areas? You can tell us. How will you find the 2 shaded areas? You're about to do an exercise, a practical one right now. That's why I'm walking you through this. Yes, Maxwell.
You do A plus B, the red side plus the blue side.
Fantastic. That's it. No subtraction, nothing. A plus B. In other words, you find the probability for the A, you find the probability for the B, you sum them. Very good. Now, how do you now find the probability? Here is some rule for you. Yes, Stella. The value at the edge, the spaces you are looking for, they are known as a random variable. So you are usually given the random variable. You will use the random variable to find the z value. You see, any random variable can be standardized using the standard normal distribution table. What is that? Any number, money, height, kilograms, inches, anything in any unit of measurement can be reconverted into a normal z value. So you can see that I've labeled this as z, which starts from the middle is what? Is 0. And going to the right is a positive value, and going to the left is a negative value. But this same z value is also the random variable x, where the mean is rather the center, and the other x's are to the right, the other x's are to the left. So every random variable x can be converted, transformed into the standardized normal distribution. Once you have gotten the standardized normal distribution, oh, by the way, how do you convert it? You use this formula to do the conversion. This formula is known as a z formula. Once you have done the conversion and you now know the z formula, the z value, you convert the z value to the probability value. And then you can do your manipulations. That's what we're about to do, right? That's exactly what we're about to do. So we're going to take a typical example and then we'll walk ourselves through that. I'll do the first one and then I'll let you do the others. Bogas, very well known, they sell furniture and carpet. From years of sales record, management found that the mean number of yards of carpet demanded by customers during a week is normally distributed with a mean of 4,200 and a standard deviation of 1,400. Now, you remember that in binomial, there was a trick on how to see that a particular question is binomial question. Another is Poisson question. Now, who can tell me, what do you think is a clue to know that a question is a normal distribution question, like the one we are doing? What are some of the clues that will let you know that, oh, this question is about normal distribution? Eugene. Eugene.
Hello. So the question states that the customers demanded is normally distributed.
Okay.
The carpet demanded by the carpet is normally distributed.
That's an easy way to start, but you will never get that in an exam question. So what will be the guide? Who has spotted it? In the normal distribution question, you will always have the mean and the standard deviation given. That's a clue. You will always have the mean and the standard deviation given. Now in Poisson, you may be given the mean, but not the standard deviation. In normal binomial, you'll be given the probability, you'll be given the sample size, but not the standard deviation. So that is where you get a picture there. You have both the mean and the standard deviation. That's what you're doing. Okay. Once you have the question, before you even look at question 1, 2, and 3, the first thing you got to do is to draw. That's it, is to draw. Please remember that I've given you this Z table. We'll come back to it. But the first thing you want to do is to draw. Draw what? Draw the mean and draw the standard deviation and label it. So the first thing you do is that you're going to draw something like a normal distribution curve And please use pencil so that it look good. Then you will indicate the center and you write mu is equal to 4,200. You have to write it there. And below that, directly below that, you write a sigma, which is a standard deviation. In this case, is 1,200. And then you go to the questions. The first question. The first question says that the store manager wants to know the probability that the demand for carpet will exceed 6,000 yards. You're about to draw that, because that drawing will carry mark. How do you identify 6,000 yards? Is it to the right of the mean or to the left of the mean? Anybody? Eugene.
To the right of the mean.
To the right of the mean. So what you got to do is that you just identify a point here, call it 6,000. So that is a vertical line. Now, we have to shade that area in question. Which area are we going to be shading? Is it A? Is it B? Is it C? Is it A and B, B and C, A, B, C? What? Which area are we shading? Maxwell?
C.
B.
D. C.
Now you're changing it, man, because
I didn't change. You didn't hear me well.
I said C, eh?
Yes, please.
Very good. So you shade the C like that. So that is the area we are now looking for. Now, to get that area, who can walk us through the process? How do we first find what? Or do what? What do you find? What do you find? Remember, this 6,000 is the X. So actually, what we are writing is that we are looking for probability that this X is greater than 6,000. That's how you should write it. This is how you write it. Then you write equal to. You're about to find. Yes, Master. How do you work it?
Okay, so we'll find the Z with the figures given. So Z is equal to 6,000 minus 4,200.
What I mean is that looking at just the graph, what will you find? How will you arrive at your probability that X is above 6,000? That's all I'm asking. Rashid.
You would find the probability that X is 6,000 or less, and then subtract that from 1.
No, you can't find the probability that X is 6,000 or less, because the probability that X is, did you say, and subtract that from what?
And subtract it from 1. So 1 minus.
So some few minutes ago, I indicated to you that the maximum value of the table is not 1, but it's 5. If you see it here. So you should be taking your mind more away from the 1. Because when you say you subtract it from 1, that is correct for the A plus B. But since we are dealing with the table of maximum value of 5, you are actually looking for what on the graph? Rashid, what are you actually looking for? What are you supposed to find first before you find above 6,000?
I'm still thinking about the answer, please.
Okay. If you are dealing with a table of 1, Z value of 1, then you would find A and B and subtract. You find the probability of A and probability of B, add them and subtract from 1. But this case, you will rather find the probability of B alone, because that right-hand side is 50%. So you only find B and subtract the B from what? Yeah, Richard.
And subtract from 0.5.
Exactly. Guys, these are the tricks. So we are not going to. So finding the B, how do we write it? It's actually saying that probability that X is equal to 6,000. That is the B. B is the probability that demand for carpet is 6,000. That is the area B. A 6,000 means you start from the center going to the 6,000. That's what it means. Exceed 6,000 means you jump the center space of B from the center to the 6,000. You jump that, get the value, and subtract that rather from 0.5 to get it. Okay, so now the first thing to do is to find the approximated value for 6,000 on the Z table, the Z equivalent for 6,000. Using the formula, you're going to say that Z is equal to X minus mu divided by sigma. Okay, and that means that Z will be equal to X is what? 6,000 minus mu. Mu is what? 4,200 divided by the standard deviation, which is 1,002. That will give you a Z value of what?
Standard deviation is 1,400.
Which other someone?
So the deviation is 1,400.
Yeah. Okay. So you get a standard deviation of 1,400, and then that will give you.
That will give you 1.29.
Always convert it to 2 decimal places. Write it somewhere. Always convert it to 2 decimal places. So I'll give you 1.29. Okay. So that means that the 6,000 is 1.29 standard deviations away from the mean. Now, what do you do with this Z table, with this Z value? You go and read it from the Z table. So keep the 1.29 in your mind. And let me show you how you do the reading. The Z table is a mirror image. So you will look on this Z table. Remember that the values that come, remember the value we're looking for is 1.29. So look on the far left here. Those are the Z values. So that's where you will get the 1.2 from. Then the 9 will be the numbers on the top. So this one is 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08. Okay, so this is 0.08. Before the last one is what? 0.09. So you're going to read Z, which is 1.2. So 1.2 is right here, 1.2 on the Z side. To get the 9, you need to go horizontally right till it matches the 9 at the top. Who can tell me the final Z probability equivalent for 1.29? Rashid.
0.4015.
Exactly. So when you trace it, you start walking down this pathway, you see that the value that corresponds to the 9, this is a 9, is the 0.4015. Congratulations. You are sorted. You are good to go. So that means that that is a value you had. The question is that your final answer? You can tell me, is that your final answer? And why do you say so? Yeah, Justine.
No, I think it's greater than that value. So, so you have to subtract this value from 1.
No. So you people are really enjoy the 111. You don't have to subtract this value. Let me go to Maxine.
Yeah, please, no. So you have to subtract it from 0.5 because that's from the middle to the 6,000.
Excellent. So that is how you gotta attach it. That's how you gotta execute it. Now, you will now have to rewrite your entire story. So your entire story have to be rewritten as probability that X is greater than, for this purpose, always use the greater than instead of the equal to. Greater than 6,000, which is also the probability that Z is greater than 1.29. That's how you write it. Which is equal to, then you write your 0.05, sorry, 0.5. You write your 0.5 minus the 0.4015 that you found. Because you are looking for the area above 6,000, not the center to the 6,000. And then you type your answer beautifully in your work. That's how you execute it. That is exactly how you humiliate a question. Any question? So you can see on the screen here, I've done all of those calculations there for you. The Z formula is there. You substitute it. You have the mean and the standard deviation. You get a 1.29 standard deviation. You go to your table. Then go and read the 0.4015. Then you subtract that answer from 0.5. You get 9.8%. So what does that mean? In principle, what it means is that demand for carpet next week, which exceeds 9.9 approximately, is an indication that there's a slim chance. Okay? There's a very slim chance that everybody is going to demand carpet next week. So much, it's not possible. Chances are very slim. That is exactly what we're discussing. Very good. Next, find the probability that demand for carpet will rather be 5,000 or less. 5,000 or less. I want you guys to work it and then raise your hand when you're done. Right? We have some winners. Maxwell and Maxine and Rashid and Richard. Can you privately send me your answer? Your very final answer. Your very final answer. I really appreciate your answer, Maxine. Rashid, your answer is not correct. But that's the reason why I normally want. Georgina, write your answer to me. I say send it privately to me. Maxwell Morrison. All right. Let's look at it now. So we know that we are dealing with, oh, come on, 5,000 or less. The fact that you are dealing with less means that you will get the entire area below the mean and a little of the area above the mean, because 5,000 itself is above the mean, as you can see. So this is the 5,000. You have to always draw. So we are looking for this area, but we already have the 0.5. So we read 5,000. The Z value for the 5,000 is 0.57. You always use the Z table. Now you go and read this at the Z table. So it's 0.57. So you go to your table here, you go and read 0.57. So first you read 0.5, then you read under 7. Then the value will be 0.2157. So that's the value you get, 0.2157. But remember, the shaded area requires that you add 0.5 to the answer. And that will give you 0.7157. 0.7157. That is the exact. So the probability is quite high that you are going to get 5,000 or less. It's quite high. And that is the good news that you are going to be able to get. So this was an answer. And I like the answer provided to me by Marceline in particular. She provided a very laudable answer. Later on, Richard also provided a smart answer. Class rep, are you there?
Yes, please.
I want you to give the following marks for me.
Yes, please.
So you're going to give, I think you yourself, you're part of that. Forgetting who's you. So Rashid,
Yes, please.
you have 5 marks.
Thank you.
There is another person, Richard and Emmanuel.
No, we have 2 Richards. There's a Samuel and there's Dapa. I think there's someone.
It's a Samuel, it's a Samuel. Samuel has 4 marks.
4 marks. Yes, please.
Kumsin has 4 marks.
We have 2 Kumsons, please. There's Emmanuel and there's Brian.
Esinam has 3 marks.
Listen. Sorry. Doc.
Maxwell Morrison has 2 marks. Maxine has 2 marks.
Yes, please.
That's all.
Doc, the Kumson, we have 2 Kumsons. Is it Emmanuel or Brian?
Emmanuel.
Please, how many marks again?
Emmanuel Kumsin is 4
Yes.
marks.
4. Okay, thank you very much.
All right. So that's how you execute it. Let's go to this very question. The probability that demand is between 3,000 and 5,000. I want you to find that. Let me know. Find the probability that demand for carpet is between 3,000 and 5K. Remember to use your table. Remember to use your table. All right. So again, I'm giving you 5 marks to execute that one. Guys, remember that I could easily give you that. Yes, James, why is your hand up? Remember that I could easily give you the answers without telling you to go through this ordeal to give me an answer. I could easily give you. but I want you to participate. Okay. So this is a graph that you're looking for. 3,000 to 5,000. The first thing is that you should find the 5,000. We already have that. It's 0.2175. So we just need to find the 3,000. And 3,000 will give you negative 0.86. You don't need to go and read a negative value. You just need to read the absolute value, which is 0.86. Once you read that from the table, whatever z value you get, you're going to get 0.3051. And you add that to the 0.2157, then you are done. So when you do that, you're going to get 0.5208. Majority of you who have sent me that answer, you did it correctly. Majority of you. A few did not do it correctly. The majority of you did it correctly. I'm not giving marks to that. I'm not giving marks to a one-time answer provision. I'm giving marks to full participation. But this is for you yourself, and it has helped you and it will help you also. Okay, any question? So now you've learned how to move. Okay. Everything we've done, you can do it also in Excel. In fact, in Excel, I did send you an Excel document. If I did not, confirm it so that I will send you.
No, Doc, we didn't get an Excel document.
Not sure.
Yes, very.
Remember last week I sent you a biennial Excel, Poisson Excel. Remember
No, it was in your slide, and you said we should try it, but you didn't send it.
I know. In my slide, do you remember I sent you biennial and Poisson? Binomial and Poisson.
I think it's only the binomial you asked us to compute in an Excel sheet as we should just try it. That's what you said, but you didn't send it. So
Okay.
I'm just looking at the semantics. Yes, please.
Okay. So you mean I did not send you? I didn't
No,
send.
please. No, please. I'm very sure.
Can you just confirm on the Excel because I've just sent to Ryan?
In the WhatsApp group.
Yes. Just check right now. Let's check right now. I've sent something. Now I'm going to show you the Excel, and then I'll show you how to find some of these things in Excel. It's just a way of how to find some of these things in Excel. So you can see in this Excel, you cannot see them. In this Excel, there are some X variables, random variables, which is 500, 550. You can see them. 500, 560, 600, 650, and on and on. And out of these, I've generated the mean. I've generated the mean, which is the average, which is 750. And then the standard deviation has been fixed at 100. Okay. We need to be able to find the probability that if I pick a variable, okay, that variable is going to be 500. How do you do it? This is the formula for probability calculation, normal probability distribution calculation. You must know the X variable. In this case, I just mentioned that the X variable is this my 500 that I want to do. So I will create a formula. And watch the formula. I have to select one, the X variable, and the X variable is my 500. Two, I have to select the mean. The mean is the 750 at the top. But you can see that the moment you select the mean, you have to press the F F4 key. The moment you select the mean, you have to press the F4 key so that you will constantize that value of the mean, so the subsequent formula will just pick it directly. So you see that there's a dollar in front and behind the D. And then finally, you select the standard deviation, which is below the mean, which is 100. And you also constantize it by pressing the F4 key. That will dollarize that cell, the letter in that cell, before and after it. Now, the last thing is, because we are not calculating cumulative density function, we choose false. Other than that, you have to choose true. So you enter, and that will give you the value, as you can see here. Okay, so you can see that that will just give you the value for the 500. And you can just move the cursor. The cursor is just not showing, I don't know why. Okay, let me just share my entire computer screen. So when you normally move the cursor to the bottom right, you see a plus symbol, which is black. You just double click quickly and all the other formula, all the other results will populate. Okay, so that is the probability density function. The fx, the capital Fx is a cumulative. The only difference between the first one and this one, I mean the fx in small letters and this one, the only difference is just what is the same thing. The only difference is that the cumulative density function has been given as what? True. That is why that is true. So once you've generated all of these for both the fx and the capital Fx, that's it. You're done. I've also drawn some of the distributions just so you see the difference between the cumulative density function and the normal distribution. But let's go to the slides and check something. In the slides, you are being asked to address some questions. Question one is, what is the probability that if I should, pick a customer, because this is a distribution of customer demand. Okay. What is the probability that at most 900 units, will be demanded? At most 900. So when you come to your Excel, how do you get at most 900? At most 900 is here. This is the 900. At most 900 means any number before 900. At least is 900 and above. At most is from the 500 all the way to 900. So we're going to do for 500, 550 all the way. That is where the cumulative probability will give you the answer. So the answer will be this cumulative probability value, which is a 0.9332. That is at most. So when you check it, you see that I have the answer here as 0.9332. The next one is, what is the probability that demand will exceed 700? Will exceed 700 means that you're having this 750 all the way to the end. That is the will exceed 700. So you take all of that and sum them. Oh, sorry. If you are summing them, okay, then you are taking their, If you are summing them, then you are taking their probability, not cumulative probability, but we want to take the cumulative probability. So you will take this number, this one here. Okay. So if you check, because we are talking about will exceed 700. I think it's supposed to be will exceed 750 and not 700. And that should give you the cumulative probability value. after the 750. After the 750. And then the last one is between 700 and 900. Between 700 and 900 is here, okay, between these two values. So what do? You take the 900 cumulative, which is a 0.933, you subtract the 700 cumulative, which is 0.3085. The difference will give you the between. So I've done that one here, and you can see that as well. Okay, now, the next most important thing. You remember I told you that when you are looking for the probability, you are given the random variable, you convert the random variable to a z-value, you convert the z-value to the probability. Now we are going to go backwards. What if you have rather been given the probability? You have to use the probability to get the z-value, and then now have to use the z-value to get an x-value. So how do you find the x-value for a known probability? Well, it's the same thing. It's the same change of subject. Remember the z function. It is x minus mu divided by sigma. And now you are looking for rather the x. So if you're looking for x, you can do change of subject. Okay. You cross multiply the z by the sigma, you are left with, on the right hand side, okay, then the minus mu becomes plus mu. Then you have the x standing. So we can use this principle to get to the answer. But it is the nature of the question that is hard. I beg of you, whatever you are doing so far, if you have not been paying attention, I beg you, this is the time you get up on your knees, take some 10 seconds walk and be alert. Okay. So let's take an example to be able to appreciate it. Suppose the price of waakye is normally distributed with a mean of 8 cedis and a standard deviation of 5 cedis. Question. I want you to find the price of waakye so that only 20% of all the prices are below this price. What are you finding? You are not finding probability. It didn't say that, what is the probability that waakye blah, blah, no. I want you to tell me the price of waakye. But from the question, you have already been given some prices, which is the mean and the standard deviation. Which means that if you draw it, you get a better understanding. So how do you do that? Let's check it. Oh, what did this thing? Let me show the question so that you can appreciate the question. And then we are going to draw it together. Okay. So you have your normal distribution curve here nicely. You indicate the mean. What is the mean? What is the mean? Rashid.
8 cedis.
So you write your ACD. What is the standard deviation, Rashid?
5 cedis.
You write a 5 CD below. And now, watch the question carefully. You're not supposed to, he's not telling you to find the probability that something is above the 8 or below the 8 or no. He's rather saying that find a certain price. So watch something. Everything I've written here, this 8 is a random variable x. The 8 is a random. In terms of z, what is the value of 8? You can tell me. In terms of z, what is the value of 8? This is where I give marks. What is the value of 8 here? Rashid?
0.2.
No. So near, yet so far. What is the value of 8 in terms of z? Emmanuel?
It's 1.0.
1.0. No. Richard?
So minus 0.84.
No. I don't know where you're picking your values from. You're picking your values from documents. The question was simply in terms of Z, what is the value of 8? I'm asking you a question. We'll go to this watch matter.
In terms of Z,
and Rashidi wants to speak more. Rhoda.
No, please 0.52.
No. What's this?
0.84.
That's wrong. I'm not even asking you to calculate anything. You see, others are going to guess. The way the thing is going, it's all going to now be guesses. The value of Z is 0. Somebody will probably said, I was going to say it. The value of Z is 0. I told you that the 8 here is a mean. And I told you that the mean value is always corresponding to a Z 0. Maybe you should write it down. The mean value corresponds to a Z value, which is 0. Mean is 0. Mean is 0. All right. So now we are looking for a price. And we can find this price if we get the value of Z. But we can't get the value of Z. It's very strange the way some of you have just moved forward and telling me answers that I'm expecting in the end because you're having the note. You're picking answers wrongly. That's not why normally I want people to think more than just looking on the note. When I'm teaching you, you should not have your note with you. It will help you to focus and pay attention. Yes, Justice. All right, so look at the question. Say now find the price of water so that 20% of all the prices are below this price. 20%. 20%. Now watch this. The entire space of the probability, the normal distribution, is how many percent? The entire space is how many percent? The entire space from the left all the way to the right, like this. Maxwell.
100%.
100%. So 20%, is it to the left of the mean or to the right of the mean? Brian.
To the left of the mean.
Good. So 20% is to the left of the mean. So we are just going to identify an area. Remember the 20% is the percentage is a probability. Any percentage. So we're going to identify a point here, and then we shade the area. Okay. But that 20%, according to the question, we are looking for a price that corresponds to this 20%, but it is below this price. So the 20% is below. So we are looking for an area that is below this price. Now, if you look at my shaded portion, A, B, and C, which one is going to represent that area we are looking for? A, B, and C. Which one is going to represent 20% of all wache prices below this price? Yes, now.
Say,
I guessing.
no. I'm not getting, I'm sure.
Okay. Because so many have been guessing today a lot. So this point here is going to be 20%. Okay. Now, but then what are we looking for? We are not looking for that 20%. We are looking for this price, that question mark price, because we don't know the price. What we know is that 20% of all the prices are below. So that means that B plus C is how many percent? That means B plus C is how many percent?
80%.
Yes, now.
80%.
80. So what is B?
B is 30%.
30%. Now, Dorcas, which one are we going to pick from the table? Is it the 20% or the 30%? Which one are you going to read from the table? Is it the 20% or the 30%? Okay, it's open. Anybody?
The 30%.
Why?
Because you are trying to find a price for the 20%.
No. This one is mathematical question. Why? Why are we finding 30%? Brian?
Because you always read in the middle
Sorry?
from the center.
Emmanuel.
Because the 20% of the shaded area represents the prices that are below the 30%, which is 20%, which is what we are trying to find.
I can't hear you.
Please,
Oh, yeah,
30%.
I couldn't even hear you. Come.
Please, can you hear me? Please, can you hear me?
Yeah, raise your distance a bit.
Yeah, please. I was saying that the 20% represents the price that we are going to find, which is 30%, represents the price that is below that point, which is the 20%, which is the shaded area. So if you want to find the percentage of the shaded area, it is the point after the point below the 30%, which is the 20%.
Yeah, your explanation is not explicit. It's not clear. Let me get another person's idea. And if you could mute your area too. Yes. Who will give us? So here's the thing. The area in focus is at 20%. But as we have always been saying, that 20%, which is a probability area, anytime you're going to find any probability, you got to jump the B area first. If you don't jump this B area, you cannot find the 20%. And so the area that we are interested in is this 30%. Because normally when you're moving from X to the probability, if you're looking for the probability, this time just that we are not looking for the probability, but if we are looking for the probability, what you will do is that you will normally bypass the B and subtract that B from 5%, 50% before you get a 20%. So it's the same pathway that we are going to follow. And that is why we need to find the B. Because once we find the B, we would have known the 20%. So the 20% is not the focus. The focus is the B. That's what we do. Yeah, Doctor, your hand is up. All right. So take note of that. It's very, very crucial. I'll not lie to you. Very, very crucial. Okay. So now we are going to look for 0.3. How do you get 0.3? Well, at this stage, you got to go to your Z table and look for a number or numbers closest to 0.3. So let's go to the Z table. You're going to search the entire space. Remember that we are looking for the probability value which is closest to 0.3. So that means that you need to comb the entire area here. This is the entire area. We're going to comb this entire area here and look for a number or two numbers closest to 0.3. Which number is closest to 0.3? You see the way they have been arranged, Rashid?
0.84.
0.84. No. I said you're looking for a probability value closest to 0.3. I don't know where you guys are getting the 0.8 for all of a sudden. Sabina.
Doc is 0.2995.
That's it. So you see the number closest to 0.3 are here. That is a 0.2995 and 0.3023. Of course, the closest one is a 0.2995, not the 0.3023. And if you want to know the closest one, just subtract each one of them from 3.3 and you will know the absolute value. The one with the smallest absolute value is the one that is closest to 0.3. So now that we know that the value is 0.29995, you can now read its corresponding Z leftward to get 0.8 and the other corresponding Z upward to get 4. So that gives you 0.84. That is what you guys are mentioning since 1912. You have been mentioning 0.84, 0.84, 0.84. I don't know how you are getting this value, whether you are picking it from some places. But this is the value of the Z that you are looking for. But there's a slight problem. It's a slight problem because this value is, you picked it as a positive value, but it's supposed to be negative. Who can tell me why it's supposed to be negative? Why should this value be negative? No.
Because it's on the left side of the mean.
That's it. It's because you see, if a person doesn't remember that it's on the left side of the mean, that person will get a bit. Okay. Remember, we are looking for the price. And as you can see, the price itself is on the left side of the mean. So whatever value you get should be on the left side. So we have gotten the value. It's actually 0.84. We know that is 0.84. But we want, this is a Z value, and we want its corresponding price. So how do we get that? Come to this x. X is equal to mu. Mu was given as what? 8. Plus Z. The Z value is a negative because it's negative 0.84. And finally, the sigma is 5. So you can now take a calculator and then simplify this answer. And that will give you what? So what will be the value of x? Most of you, Emmanuel, it looks like you have a noisy value. Who can tell me the value you got? You should get 3.28 or so. So that is going to be the x value, the random variable. And truly, it is on the left side of the mean, which means your calculation is correct. So what does this mean? It means that 20% of the prices of Wache are actually below 3 cedis and 28 pesos. That's what it means. 20% of the prices are actually below, which means that the rest of the prices, that 80% of the prices are above. In fact, you can use this principle to find all the highest price. I can ask you, what is the highest price? Okay. What is the highest price of Wache? That corresponds to 100% if you are moving rightward. But somebody should be able to tell me the highest price. Who can tell me? Come on, you got to be incredibly smart. Take a guess. Take a wild guess. What is the highest price of Wache? What is the maximum price you can charge? Don't think too much. Don't think too much. Okay, let me give you a clue. The maximum price you can charge. If the center price is 8, see this, what's the maximum price? Yes, now.
16.
You see, you got it now. That is it. That is it. That is it. Yes. Okay, now, so this question actually said, find the price of Wache so that only 20% of the prices are below this. But let me show you something. What if the question has been, find the price of Wache so that only 40% of all Wache prices are below this price? Okay. If it has been only 40 instead of the 20, how would you have worked it? How would you have worked it? By the way, everything I've said is here. If it was only 40%, what will you read? What probability percentage value will you read from the table? Let me go up here. Suppose it was rather 40% instead of 20%. What probability will you search and find this corresponding Z? Sabina?
0.1.
Exactly. You search for 0.1. Now, but what if that you've been told that, now this is a bit tricky. I'm giving you all of these possibilities because you're going to have them in the exam. What if you've been told that find the price of Wache that corresponds to 60%? This is tricky. That corresponds to, that corresponds to 70% of all prices, of all Wache prices. Okay. Watch it. Write it down. Find the price of watch that corresponds to 70%, okay, of all watch prices. Find that price. Find that price that corresponds to 70% of all watch prices. What are you going to read? What are you going to read? Let me see. There are obviously smart ones here. What are you going to read? Richard. Richard.
Say, sorry, I'll read 20%, but this time to the right.
Exactly. You read 30% and this time to the right. Excellent. Now, guys, why? The reason is because if you look at the normal distribution here, this is the 8. Okay? And we said that this is 20%, and the whole of this is 50%. So if you are told that you should get 70%, 70% will start from all the way here, going to 100. So 70% will be here. Oh, did you say you read 30? 30 is wrong, by the way. You rather read 20. So if this is
20.
If this is 50%, then what 70% is up to here. It's all the way up to here. That is the 70%. Okay, so that means that here is what? 20%. And then this part here is 30%. And the question was asking you the probability that 70% of all prices belong to this price. That's what you're looking for. And that 70%, 50% will go to the left here, so you don't need it. 20% goes here. So 20% is what you read because you read from the center to the right. So you go and read 0.2 on the Z table, and you find its corresponding Z value. And then you come and substitute it into this formula. Okay. So look at the question. The reason why we use this one was because of the word below. For example, the question could have been, find the price of watch so that the top 20% of all prices are above this price. You see the way it is? The top 20% of all prices are above this price. So in that case, we are talking about the top 20% here. And that top 20% here means that you're going to have 20%. So we are going to read 30%. And that is what we need to read to get it. And then make sure that this time it is positive because we are talking about the top 20%. Yeah. Familiarize yourself with these things, and that will help you shape the entire circumference of your statistics. Okay. Finally, this one we're not going to do much of it. It has to do with exponential distribution. The normal distribution that we did, in terms of probability, I've also given you an Excel version for you to check how to calculate that. It's very simple. All you got to do is to know the probability. Once you know the probability and you know the mean, you can find the X. Let me end with this simple question on exponential distribution. Exponential distribution mainly looks at time. How long it takes somebody to do something. The time it takes you to get the exam written. It describes the time it takes to complete a task. Time. The time between vehicle arrivals at the toll booth. Time. This is very useful when you're doing queuing models. The time needed to complete a questionnaire. Time. The distance between major defects in a highway. Time. Distance. There must be an interval, a gap. The time it takes to complete a football match. Time. That is exponential distribution. Now, all of these are samples. Okay? Time between trucks arriving at an unloading deck, time between transactions at an ATM machine, time between a phone call to the main operator. I don't like waiting on a phone call. Can you hold? Please hold. That's what they keep saying. Please hold. And then they start playing you some classical music. Okay. Now, the cumulative distribution function, that is the probability that an arrival time is less than some specified value. This is the formula. Like the normal distribution, we're using the Z approximated formula. This one, we are just using 1 minus you know, the exponential value, and then you have the mean there. It's slightly similar to the Poisson. But the mean, the lambda is a mean of the occurrence per unit of time. And then the x is the one inside the question. And then the e is a natural log 2.718. That's it. Let's take a simple question, one question, and we are done for today. Oh, by the way, remember that the mean is also the standard deviation, just as it was with Poisson. Everything about this is like that. Customers arrive at the service counter at the rate of 15 customers per hour. I see, he didn't say 15 customers per hour. I'm just adding the customers, but it's actually that. So the number of customers that enter the service counter are 15 customers every hour. What is the probability that if I pick a customer at random, the arrival time, what is the probability that the arrival time between the next customers is less than 3 minutes? So the word is less than 3 minutes. Less than 3 minutes means 2, 1, and 0. Remember, we are talking about an hour, which is 60 minutes. What is the probability of 11? And how do you work it? It's very simple. And how do you first of all know that this has to do with exponential? Who can tell me which word guides you to know that this is about exponential distribution? John. Brian.
Yeah, arrival time.
Exactly. Arrival. And also, which word? Did you say arrival time or arrival? If you said arrival time, then you've combined both, which is okay. Okay. So the lambda, which is the mean, has been given as 15 hours. Now, how do we know that the lambda is a mean? Because it's in the question. It says at the rate of. So it's like it's giving you the average. In other words, the average number of customers arriving, are 50 customers every hour. So that's the average. If I use the word at the rate of 15 per hour, 15 per hour year means 15 customers. So that's the mean. I said the mean has been obtained. Then it says 3 minutes. 3 minutes. Now, if we're talking about 15 customers every hour, okay, by the way, this word should be hour, not hours. If you're talking about 15 customers every hour, that is every 60 minutes. How many customers are every 3 minutes? Or how many hours is that? If you want to convert the customers to hours. Customers to hours. So 3 minutes, how many hours is that? It's going to be less, right? So if let's multiply, Georgina. Georgina, it's your hand up.
Yes, sir. Please, it's 0.05 hours.
Good. Good. So that's it, it's 0.05. Now, the reason why you are doing this is because the original mean is in hours. That's why you're doing this. Okay, so you got this value. Now, you can put in the formula because that's all you need. You get 1 minus 2.718 raised to the power negative lambda, which is a 15 hours, multiplied by the x. Now, remember, he says less than 3 minutes. So we'll come back to that. And then you multiply all of them, you get 0.53278. Remember, everything you are getting is in average. It's in average terms. So what does this value here actually mean? Okay. So 52% probability that the arrival time between consecutive customers is less than 3 minutes. Because exponential distribution carries a lot of information in Poisson. To be honest, and uniform, I will not give you a question on that. But it's just for you to know that this is our exponential distribution. Ladies and gentlemen, that brings us to the end of the entire tableau. Now, at this stage, if you have a question, you can ask me, but please know that I've given you the formula for the binomial, the formula for the Poisson, the formula for the normal distribution, both the mean, you have the mean and the standard deviation, but also the probability density function has been provided. And finally, the exponential distribution formula has been given to you. Any question? Now, in week 7, you'll be doing a midterm exams. So be prepared. Next time we meet, we are going to look at hypothesis testing. And you are going to understand how to hypothesize. You will also meet some of these hypotheses in